Hi all, welcome to my channel 100% Concept Clear. In this video we are going to discuss about unbalanced problem and maximize type in assignment problem. If you want to watch the same video in Tamil, link is available in the description box. Let's get started the video. Here the question. Find the optimum assignment of jobs and corresponding profit. So in my previous video, I have discussed the basic concept of assignment problem. If anybody want to check that, link is available in the description box. In that video, I have clearly explained that always profit should be in maximum. By seeing the single word profit itself, we can find that all the given element here represents profit. Hence, the given sum is maximized type. Let's solve this problem with algorithm. Algorithm for Hungarian assignment problem, step 1. Check whether the given assignment problem is balanced assignment problem. So we are asked to check whether the given problem is balanced assignment problem. So which means number of rows and number of columns should be equal. That is, if number of rows and number of columns are equal, it is a balanced assignment problem. If it is not equal, add the dummy row or dummy column which is required and give zero cost or profit. Number of rows and number of columns are not equal, then the sum will be unbalanced assignment problem. So we have to convert that into a balanced assignment problem by adding a dummy row or dummy column. So if there are not sufficient rows, we can add a row, or if there are no sufficient column, then we can add a dummy column, and we have to give the elements as a zero cost or profit. So let us apply the step 1 in the problem. So as per first step, we should compare our rows and columns to find whether those are equal. In row wise, we have 1, 2, 3, 4. 4 rows, and in column we have 1, 2, 3, 4, 5 column. So we have 4 rows and 5 columns. Therefore, it is not equal. Number of rows, that is machine, is not equal to number of columns, that is job. We have 4 machines and 5 jobs. Therefore, it is unbalanced assignment problem. Now, we converted this unbalanced assignment problem into a balanced assignment problem by adding a dummy row. Here, the row is insufficient, so we added a dummy row. In case if column is insufficient, we can add a column. So we can add which is insufficient. Here row is insufficient, so we are adding dummy row. See here, dummy row is included and profit is given as zeros. So step 1 is completed. Now check what is step 2. Step 2 in algorithm is row reduction. There we have 2 cases as we discussed earlier. The first one is if it is a minimum cost or time sum. The second one is if it is maximum profit problem. So if it is minimum cost or time, that is if we are asked to find out the cost or time in minimum, choose the least value in the row and subtract it with all the elements in the row. So we have to find the least value in the each row and we have to subtract that with the other elements in the same row. Or if we ask to find the maximum profit, if it is maximum profit problem, then the step is choose the maximum value in the row and subtract it with all the elements in the row. So if we ask to find out the maximum profit, we have to choose the maximum value in each row and subtract that with each element in the same row. So let us apply this in a problem. This problem is maximize profit problem, so we are using the second one. So as per row reduction, we must select the maximum value because it is a maximize profit problem. So check in first row, we have 82, 78, 50, 101 and 82. Here 101 is maximum value. And in second row, 71, 84, 61, 73, 59. Here 84 is maximum value. And in third row, 87, 92, 111, 71, 81. Here the maximum value is 111. And in fourth row, 48, 64, 87, 77, 80. Here the maximum value is 87. And in fifth row, all are 0, we can choose any one. So see in first row, 101 minus 62 is 39, and 101 minus 78 is 23, and 101 minus 50 is 51, and 101 minus 101 is 0, and 101 minus 82 is 19. Now see in second row, 84 is maximum value, so 84 minus 71 is 13, and 84 minus 84 is 0, and 84 minus 61 is 23, and 84 minus 73 is 11, and 84 minus 59 is 25. Now in third row, 111 is the maximum value, so 111 minus 87 is 24, and 111 minus 92 is 19, and 111 minus 111 is 0, and 111 minus 71 is 40, and 111 minus 81 is 30. Now in fourth row, maximum value is 87, so 87 minus 48 is 39, and 87 minus 64 is 23, and 87 minus 87 is 0, and 87 minus 77 is 10, and 87 minus 80 is 7. And in fifth row, all are 0, so just enter that. Now step 2 is completed. Let's check what is step 3. Step 3, column reduction. It is same for both minimum and maximum problem. So that is, choose the least value in each column and subtract it with each of the element in column. That is, we have to choose the least value in each column and subtract it with balance element in the same column. So let us apply this in the problem. So as per step 3, column reduction, we must find the least value in each column. So see in first column, 39, 13, 24, 39, 0. So 0 is the least value, so mark that 0. And in second column, 23, 0, 19, 23, 0. Here also we have 2, 0, we can mark any one. I am marking this. And in third column, we have 51, 23, 0, 0, 0. So here 0 is the least value, we can mark any one 0. So I am marking this. And in fourth column, 0, 11, 40, 10, 0. Here also we have 0 as least value, so mark 0. And in fifth column, 19, 29, 30, 7, 0. Here also we have 0, so mark that 0. After selecting the least value in each column, we should subtract the balance element in the column with this selected element. Like 39 minus 0, and 13 minus 0, 24 minus 0, and 39 minus 0. So in the sum, all the least value are 0. So if we subtracted any number with 0, the answer will be that number only. So there is no need to again write this as a column reduction. Now step 3 is completed. Now check what is next step. Step 4, zero scanning. Draw the minimum number of horizontal and vertical lines to cover all the 0. Here we have to draw the minimum number of horizontal and vertical lines to cover all the zeros. If number of lines drawn is equal to number of rows and column, that is, number of lines is equal to order of matrix, the solution is optimal, and proceed to step 7. If the number that we have drawn is equal to order of matrix, then the solution is optimal. We can proceed to step 7. If not, we have to go to step 5. So first draw this number and check whether the sum satisfies this condition. For scanning 0, just rewrite the element that we got in column reduction. So in step 4, we have 2 conditions. That is, first condition is we should draw only the horizontal and vertical lines. Horizontal lines means like this, and vertical lines means like this. So we can draw only the horizontal and vertical lines and not cross lines like this. So this is the first condition. And second condition is the number of lines that used to cover the zeros should be in minimum. That is, see for example, here we have 5 zeros in this single row. So to cover this 0, single line is enough. But instead, if we used 5 lines to cover the 0 like this, 1, 2, 3, 4, 5, then that will be the maximum number of lines. So our condition is we should cover the zeros in minimum number of lines. So one single line is enough to cover these 5 zeros. So that is the second condition. For drawing lines, we can either draw lines randomly, but in that case there is chance to miss out any zeros. So instead of that, we can use a process called assigning jobs. So to the assigning jobs, first we have to take the first row and check whether it has 1 0. So if it has 1 0, we should mark that 0. Or if it has 2 0, we should skip first row and move to second row. In second row also, we should check whether it has 1 0. If it has 1 0, we can mark that 0. Or if it has 2 or more 0, we should skip that row and move to third row. Likewise, we should do in all rows. Once row is completed, we should do the same in column also. So that is how to draw the lines in assigning jobs. So let's do that. Check in first row, 39, 23, 51, 0, 19. Here we have 1 0. So we can mark that 0. So another rule is if we marked in row wise, we should cancel in column wise. So here we marked this 0 in row wise. So we should cancel in column wise. Now check in second row. In second row, 13, 0, 23, 11 is cancelled and 24. Here we have 1 0. So we can mark that 0. So mark that 0. Now we marked in row wise. So we can cancel in column wise. Now check in third row. In third row we have 24, 0, 30. Here also we have 1 0. So we can mark that 0. So mark that 0. And now we marked this in row wise, so we can cancel in column wise. Now check this row. In this row we have 39 and 7. There are no zeros here, so skip that row and move to fifth row. In fifth row we have 0, this 0 and this 0. So here we have 2 zeros, so also skip that row. Now we completed in row wise. Now check in column. In column we have, see the first column, 39, 13, 24, 39, 0. So in column wise we have 1 0. So we can mark that 0. Now we marked this in column wise. So we cancel in row wise. Here we marked this in row wise. So we cancel in column wise. Here we marked this in column wise. So we cancelled in row wise. Now check whether we have covered all the zeros. Check in first row we have covered this, in second row we have covered this, and in third row we have covered this, and in fourth row also we cancelled this, and in fifth row also we cancelled everything. So now all the zeros are covered. Now check the condition. Our condition is the number of lines drawn should be equal to the order of matrix. So now count the number of lines that we have drawn. See, 1, 2, 3 and 4. So we have 4 lines. Now check the order of matrix. It is 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. It is 5 into 5 matrix because we have 5 rows and 5 columns. Therefore, number of lines is not equal to order of matrix because we got 4 lines and the order of our matrix is 5 into 5 matrix. So 5. Now check what to do next. As per step 4, we have drawn the minimum number of horizontal and vertical lines to cover all the zeros and checked whether our sum satisfies the condition. If it satisfies the condition, we can go to step 7. If not, we should go to step 5. Our problem didn't satisfy this condition, so now we should go to step 5. Step 5. Select the smallest uncovered elements. So what is uncovered elements? Uncovered element is where no lines are covered. So select the smallest uncovered element and add this element to all the intersection of 2 points and subtract this element from all uncovered elements. Let's apply this in sum. So as per step 5, we have to do 3 things. First one is we should find the smallest uncovered element. So uncovered element is the element where no lines are crossed. So see here, 39 and 13 and 24 and 39 and 19, 29 and 30 and 70. These 8 elements are the elements where no lines are crossed. See, the second, third and fourth column have lines, and also the last row also have line. Only 39, 13, 24, 39 and 9, 25, 30 and 7 has no lines. So these are the uncovered elements. So from these 8 elements we should find the least uncovered elements. So which is least value from these 8 elements, which is 7. So the least uncovered element is 7. And the second one is we should add this 7 in the intersection point. So what is intersection point? Intersection point is the point where two lines are crossed. Here we have two lines, here also we have two lines, and here also we have two lines. Here and all we have only one lines. No lines intersected here, but here we have two lines as intersection, here also and here also. So these are the three intersection point where we should add this 7. And third point is we should subtract this 7 from all the uncovered elements. Here the uncovered elements are 39, 13, 24, 39 and 19, 25, 30 and 7. So we should subtract this 7 from these 8 elements. So let's do that. So see in first row 39 is uncovered element. So in an uncovered element we should subtract this 7. So 39 minus 7 is 32. And in this, these are covered elements. So we should write the covered elements as it is. So 23 and 51 and 0. Because these three are covered elements, so we just write it as it is. And last 19 is uncovered element. So from uncovered element we should subtract the smallest uncovered element. It is 7. So 19 minus 7 is 12. Now in second row 13 is uncovered element. So we should subtract the smallest uncovered element from the uncovered element. So 13 minus 7 is 6. And this 0 is covered element. So we should write the covered element as it is. So 0, 23 and 11. And 25 is uncovered element. So we must subtract the smallest uncovered element from this uncovered element. So 25 minus 7 is 18. Now check the third row. In third row 24 is uncovered element. So 24 minus 7 is 17. And 19 is covered element. So we just write it as it is, 19, 0 and 40. And here 30 is uncovered element. So 30 minus 7 is 23. Now in fourth row 39 is uncovered element. So 39 minus 7 is 32. And 23 are covered element. So we just write as it is. So 23, it is also covered element. So 0 and 10. And 7 is uncovered element. So 7 minus 7 is 0. Now see in last row, this 0 is covered element. So we just write the covered element as it is. So 0. And see, it is an intersection point. So we should add the smallest uncovered element in intersection point. So this is intersection point. So 0 plus 7 is 7. And this is also intersection point because two lines joins here. So 0 plus 7, smallest uncovered element is 7. So 0 plus 7 is 7. And here also this is the intersection point. So 0 plus smallest uncovered element is 7. So 0 plus 7 is 7. And this 0 is covered element. So we just write covered element as it is. Now we completed the step 5. Now check what is next step. See the algorithm. We have completed the step 5. Now check what is step 6. Repeat step 4 and step 5 until optimum solution is obtained. So in step 6 we have to repeat the step 4 and step 5. So what is step 4? Step 4 is zero scanning. So again we have to draw the minimum number of horizontal and vertical lines to cover all the zeros. and check whether the number of lines and order of matrix are equal. So if they are equal, we can go to step 7, or else we should again go to step 5. So now we can draw the minimum number of lines and then we can check whether it satisfies this condition. So step 6, scanning zeros. Here we are going to draw the minimum number of horizontal and vertical lines to cover all the zeros. For that, first check the first row. Here we have 1 0, so we can mark that 0. So mark that. So if we marked in row wise, we should cancel in column wise. So we marked in here, we marked in row wise, so cancel in column wise. And in second row, 6 0 23 11 8. Here we have 1 0, so we can mark that 0. So if we marked in row wise, we should cancel in column wise. And in third row, here we have 17 0 23. Here we have 1 0, so we can mark that 0. So mark that 0. Here we marked this in row wise, so we can cancel in column wise. Now check in fourth row, 32 0. Here also we have 1 0, so we can mark that 0. So when we mark in row wise, we should cancel in column wise. Now check in last row, all are cancelled, only we have 1 0 here. So we can mark that 0. So if we marked in row wise, we should cancel in column wise. So now check whether the number of lines and order of matrix are equal. So count the number of lines, 1, 2, 3, 4, 5. We have 5 lines. Now check the order of matrix. It is 5 into 5 matrix because we have 5 rows and 5 columns. Now our number of lines and order of matrix is equal. Therefore, number of lines is equal to 5 and order of matrix is also 5. Therefore, now optimal solution can be obtained. See, now our number of lines and order of matrix are equal. So we are going to step 7. If not, we should again go to step 5, that is uncovered element step. So we have to perform again that. Again we have to draw the lines and again we have to check whether the number of lines and order of matrix are equal. So we have to perform this until our number of lines and order of matrix becomes equal. So now we can proceed to step 7. So step 7 is assigning job. We have already done this. So now mark the workers with the respective job. Here we have one special case. I have explained this special case in the separate video. I will give you the link in the description. Now we can assign the jobs to the each workers. See, in the first row we have marked this 0, which means machine 1 is assigned with job D. And in second row we have marked this 0. So machine 2 is assigned with job B. And in third row we marked this, which means machine 3 is assigned with job C. And in fourth row we have marked this 0, which means machine 4 is assigned with job E. And in fifth row we have marked this 0, which means machine 5 is assigned with job A. So let's write this. So we have found the job for each machines from here. Now we have to find the profit by comparing these two with the original question. So where we should check the machine 1 with D job. So see here, machine 1 job D, the profit is 101. So the machine 1 job D profit is 101. Now check what is machine 2 and job B. So machine 2 job B profit is 84. See, machine 2 job B profit is 84. Now check what is the profit for machine 3 and job C. Now see, machine 3 and job C, then profit is 111. See, machine 3 job C profit is 111. Now check machine 4 and job E. Machine 4 job E, answer is 80. Machine 4 job E, answer is 80. Now check what is profit for machine 5 and job A. Machine 5 is dummy machine, 0. Now we should add all these 101, 84 and 111 and 80 plus 0. So by adding up 101, 84, 111, 80 plus 0, The answer is 376. That is, therefore, total maximum profit is 376. If you have any doubt, leave your doubt in the comment section. And if you found this video useful, like it and share with your friends and help them to understand concept easily. And for more related topics, subscribe to my channel. Thank you for watching.